Hello everyone, welcome back to my YouTube channel. In this particular video, we'll be looking into correlation and the different types of correlation. Now, this correlation topic comes under multivariate exploration. In the previous video, we have already seen univariate exploration, which deals with a single variable and which helps us to find out the understanding about a single variable. Now onwards in this video, we'll be looking into multivariate exploration which talks about the study of more than one variable. So let's have a look at the definition first. Multivariate exploration is a technique that is used in data analysis that allows for the comprehensive exploration of complex data sets by considering multiple variables at the same time. So here we are going to study about multiple variable at once. Now this multivariate exploration is very much helpful to study the relationships among multiple variables that we have in our particular dataset. Now, the main aim of multivariate exploration is to uncover the hidden patterns that are present inside the dataset, as well as the relationships among different variables that are present in it. Now, let's have a simple example to understand what exactly multivariate exploration is. Now, here I have taken an example of wine quality analysis. Now, here in this particular example, we have taken concentrations of 13 different chemicals in wines that are grown in the same region in Italy. They are analyzed to understand their impact on the quality of wine. This is a multivariate analysis because it involves more than two variables, that is, the concentrations of 13 different chemicals. So, here in this particular data set, we have 13 different variables, and here the variables consist of 13 different chemical concentrations. Basically, this particular 13 variables are going to be useful to study the impact of all these chemicals onto the quality of wine. So I hope you're getting a basic idea that here, relying not only on one single variable, we are going to study multiple variables at once. So let's say the concentration of one particular variable is increased. What is going to be the impact on the quality of the wine? We can study with the help of multivariate exploration. Now, this is just a simple example. Here, we only have taken a scenario. We still haven't got a basic idea about how it works. So don't worry about it. In the upcoming time, we are going to study all this. Now, specifically in this particular video, we are going to look into correlation, which is a section under multivariate exploration. So let's have a look at it. Now, before jumping into the depth of correlation, first let's have an overview of what exactly correlation is. So, according to the definition, correlation is a way to understand how two things are related to each other. Mark this thing that we are going to specifically focus on two things at a time. Correlation is used to study the relationship between two variables. Now, there is a speciality of correlation. Whenever two things, that is, two variables, are correlated, then the change in one variable will tend to be associated with the change in other variable. This is the speciality of correlation. If one variable is getting impacted, then other variables will also get impacted since they both are correlated with each other. Now, I hope you are getting a basic idea about why correlation is important to study. Let's take a simple example. Happiness helps you live longer. Now, here you can see that we have two things to focus. One is happiness, and the second is the lifespan, how long you live. Now, here it says that happiness helps you live longer. That means the more you are happy in your lifespan will also increase, and vice versa. If you are not happy in your life, that means if you are less happy in your life, it states that you might live shorter. You won't live a long, healthy life. So it's better to be happy so that you can enjoy your life as well as increase your healthy lifespan. So there is a correlation among these two variables, that is happiness and the lifespan. So I hope you're getting a basic idea through this particular example. Now let's move forward and see the types of correlation. Generally, we have three types of correlation. First is positive and negative correlation. Second is the simple, partial, and multiple correlation. And third is the linear and non-linear correlation. All these three types of correlations are extremely important when it comes to data science. So let's dive in all of them one by one, starting with positive and negative correlation. First, we'll see positive correlation. Now, by definition, when one variable increases, the other variable also tends to increase. With that, when one variable decreases, the other variable also tends to decrease. This is nothing but positive correlation. The impact on one variable will have the same impact on the other variable. If one variable is increasing, the second variable will also increase. If one variable is decreasing, the second will also tend to decrease. This is positive correlation. Let's take a simple example to understand it clearly. Here we have two variables, that is number of hours spent to study and the exam scores. The relationship between the number of hours spent to study and the exam scores are positively correlated. Obviously, if you spend more time studying, then you will tend to increase the exam scores, provided that you are genuinely studying. And vice versa, if you are spending less time in study, then obviously your marks will decrease. So this is having a positive correlation between them. Graphically, it looks something like this. If we have the number of hours spent on studying on the x-axis, that is the study time, and if we have the exam scores on the y-axis, then it will look something like this. It will have a positive correlation. The more you study, the more exam score you will get. So by this graph, here you can see if you are studying more, you will get more exam scores. If you are studying less, then you are going to get less exam scores. So I hope the logic of positive correlation is clear to you all. Now let's move on to the negative correlation, which comes under the first type itself. Now by the definition, it states that when one variable increases, the other variable tends to decrease. Here, you can see the logic is completely opposite as that of the positive correlation. When one variable is increasing, the other variable will decrease. Similarly, when one variable is decreasing, the other variable will tend to increase. So this is what is called as the negative correlation. Let's take a simple example scenario. Here, we are going to take two variables, temperature and the amount of snowfall. Here, we are going to study the relationship between temperature and the amount of snowfall. Obviously, if temperature increases, the amount of snowfall in that particular span will obviously tend to decrease. Similarly, if the temperature decreases, the amount of snowfall at that particular span increases. Here, by the graph, you can see how it goes. If we have temperature on the x-axis and if we have the amount of snowfall on the y-axis. If the temperature increases, let's take this particular point, you can see the amount of snowfall is going to be decreasing. Similarly, if you take this particular point over here, in this particular case where temperature is less, the amount of snowfall is obviously going to increase. So I hope the logic of negative correlation is clear to you all. Now let's move on to the next type of correlation, that is the simple, partial and multiple correlation. Simple partial and multiple correlation might be confusing for many, but now onwards it won't be confusing at all, I promise you. Do you want to check out this attractive funny memes? Then what are you waiting for? These are just a glimpse of the memes that I've created on my Instagram page. You can find the link to my Instagram handle in the description box. Please visit the link and do watch all these interesting funny memes. These are not just memes. These memes and reels contains technical information. Here I try to relate memes with the technological concepts. So please do appreciate that by watching all those. And if you love it, please hit the follow button. Let's have a look at the simple correlation first. By the definition, it examines the relationship between two variables without considering the influence of other variables. Here, we are only going to specifically look into two variables at a time in simple correlation. Here, we are not going to consider the influence of other variables. We are going to keep in mind that the other variables are not going to impact these two variables of study. Here, specifically two variables will be used to understand the relationships among them. Let's have a look at a simple example to clarify all your doubts. The example states the relationship between hours of exercise and weight loss. Now here you can see that we are specifically considering two variables only. One is hours of exercise, and the second variable is weight loss. Here, no third variable is going to influence these two things. Yes, of course, there might be other factors that may influence these two variables, but in case of simple correlation, we are not going to focus on that other attributes. Only two will be focused at a time. So I hope the logic of simple correlation is clear to you all. Now let's move on to the next correlation, that is partial correlation. For partial correlation, the definition says that it examines the relationship between two variables while controlling the influence of one or more other variables. So here we can see that there might be more than two variables present at that particular scenario, but here, apart from two variables of study, the other variables influence will be under control. We might consider the influence of other variables as if they are constant, or their influence is constant at all the stages. Let's have a look at a simple example, that is the relationship between smoking and lung cancer. Now, the two variables of study are smoking and lung cancer, the impact of smoking on lung cancer. Here, there is also third variable that existing, which is age. But we kept this particular variable under control. That means this variable is partially acting as a constant variable. Yes, it is existing, but its influence is not that strong under this particular type of correlation. It is under control. So I hope the logic of partial correlation is clear to you all. Now let's move on to the multiple correlation. According to the definition, multiple correlation examines the relationship between more than two variables. So here, the third variable won't be under control. It may strongly influence the impact of it onto the two variables that we are studying at that moment. So under partial correlation, all the other variables apart from the two variables of study are under control, but in the multiple correlation, all the other variables, apart from the two variables that are under study, are not under control. They are going to influence the two variables that are under study. Let's have a look at a simple example to understand the multiple correlation. Here, the relationship between smoking and lung cancer is there. That means these two variables are under study, smoking and lung cancer, with the influence of age. That means smoking is going to impact the lung cancer, but with the influence of age. That means age is also one of the parameter which is going to decide the severity of lung cancer along with smoking. So here you can see the relationships between more than two variables are in study at one go. So I hope this multiple correlation is clear to you all. Now let's move on to the third type of correlation, which is linear and non-linear correlation. First, let's have a look at linear correlation. According to the definition, linear correlation states that the amount of change in one variable to the amount of change in the another variable tends to bear a constant ratio. That means if one variable is changed, the other variable will also be changed with that in the same ratio as that of the first variable. The amount of change in both of them will bear a constant ratio. The correlation is said to be linear when the relationship between the two variables can be represented by a straight line. A straight line in graph states that the change in both the variables bears a constant ratio, as we have seen in the positive correlation. Let's have a look at a simple example. Here we are studying the relationship between the price of a product and the quantity demanded. Now, obviously, if the price of a product is increasing, then in that case, you will get the more quantity of that particular product. Similarly, if you are decreasing the price of the product, the quantity will also decrease. You can see graphically, here you can see if we plot the price of the product on the x-axis and the quantity on the y-axis, you can clearly see that it bears a straight line. Here it states that it bears a constant ratio. If the price of the product is high, then in that case you will get more quantity of it. If the price of that particular product is low, you will get less quantity of that particular product. So this states the linear correlation between both this particular variable. So I hope the linear correlation is clear to you all. Now let's move on to the non-linear correlation. According to the definition of non-linear correlation, it states that the relationship between the two variables cannot be represented by a straight line. If we are not able to represent the relationship by a straight line, it means that the two variables doesn't bear a constant ratio when we are changing it. Let's have a look at a simple example. Here, if the amount of fertilizer is increased, if you increase the amount of fertilizer in your farm, the yield, the yield of crops will increase initially. But after a point, if you continuously increase the amount of fertilizer, then in that particular case, the yield won't increase. Instead, it will start decreasing. The crops will die. So here you can see both this variable, that is the amount of fertilizer, and the yield of the crops doesn't bear a constant ratio. If we graphically look into it, if we plot the amount of fertilizer on x-axis and the yield of the crops on the y-axis, then in this particular case, you can see if the amount of fertilizer at the initial stage, if it is increasing, you can see the yield is also increasing. But from this particular point, this is the peak point. From this particular point, if you are still increasing the amount of fertilizer, then in that case, you can see the yield is decreasing. There is nothing like a straight line. Here you can see the graph is something like this. So this means that there is no linear relationship between these two variables, and hence here it is a non-linear correlation. So I hope this type of correlation is also clear to you all. I hope all these three types of correlation with its example is very much clear to you all. I tried my best to clear all all the concepts in this particular topic. If you guys have any single doubt, then you can straight away put it in the comment section. We talked about correlation, but what about the case where there is no correlation at all? Let's have a look at that particular case also, where the correlation is not existing at all between the two variables. Now, by the definition, it means that there is no apparent relationship between the two variables that are under study. Now, what happens when there is no correlation between the two variables? It means that the change in one variable won't have any single impact on the other variable at all, not even in fractions. Let's have a look at a simple example. Consider the relationship between the shoe size and the IQ scores. The shoe size and IQ scores are generally not related to each other, so there is no correlation between them. Obviously, if you have a big foot, then it doesn't mean that you have a high IQ. It is not like that at all. If you agree with this particular example, then you can drop yes in the comment section. Otherwise, drop no. And with that, also give your suggestion or corrections. Now, if we look graphically, here no correlation will look something like this. Let's say if we have the shoe size on the x-axis and the IQ score on the y-axis. Here you can clearly see that if the shoe size is increasing, it is not giving any pattern that the IQ level is increasing or decreasing. They are scattered. There is no single correlation among them. We cannot plot a straight line nor even a curve. So therefore we can say that there is no correlation between these two variables. I hope the logic of no correlation is also clear to you all. With this, we come to the end of the video. I hope you enjoyed a lot. I have taken multiple examples to make you understand the concept of types of correlation, multivariate exploration, as well as the concept of no correlation. I hope you enjoyed it. If you want to enjoy the concepts of different tech stacks with the help of memes, then you can straight away head up to my Instagram page. There you will get variety of memes which are not only funny, but they are technical also. They will teach you a lot of different concepts. So what are you waiting for? The link is in the description. Go follow me on Instagram and check all the memes. If you like this particular video, please do like, share and subscribe to my channel. Also hit the bell icon and don't forget to follow me on Instagram. Please join me on Telegram. Thanks for watching. Have a good day ahead.